Hello and welcome to the SpaceX Transporter-4 rocket launch, which is scheduled for liftoff in roughly 30 minutes' time. My name is Michael and I'll be your host for this live broadcast. I'm really happy to say that I'm joined in the studio by Haraldus, a systems engineer here at NanoAvionics. He's going to be my technical sidekick for the first part of this broadcast. Great to have you here, Haraldus.
Nice to meet you, Michael.
So, thank you as well for joining NanoAvionics for this event. As a small satellite manufacturer and mission integrator, we have 3 satellites on board that Falcon 9 rocket today for this SpaceX mission. One of the satellites is the start of Omnispace's mission to reinvent mobile communications through a truly global hybrid 5G network. By integrating terrestrial and satellite networks into one seamless, connected experience, Omnispace seeks to empower consumer, enterprise, government and IoT users worldwide. Operating in low Earth orbit, their initial satellites, which are named Spark-1 and Spark-2, will support the development and implementation of ubiquitous mobile voice and data communications, connecting directly to mobile devices in real time around the world. The second satellite we have on board the Falcon 9 rocket today is named MP42. It is the first satellite based on our new MP42 microsatellite bus. It also marks the 5th shared satellite mission by NanoAvionics. That means there are multiple customer payloads integrated on board. One of them is a 5G cell tower in space, which is dubbed Tiger 3, and that's for OQ Technologies' 5G IoT and machine-to-machine communication constellation, which is following on from a successful launch and test of their Tiger 2 mission on board another NanoAvionics manufactured satellite that was launched last year. The MP42 also hosts Veoware's fully integrated reaction wheel for high-performance satellite altitude control with next-generation high-torque, low-power technology. They'll run various in-orbit tests with it on board the MP42. There is even more payload on board the MP42, and we'll talk a little bit more about those later on in this broadcast when the Falcon 9 rocket is in its coasting phase. The customer of the third satellite we are launching today does not want to be disclosed, so we're mainly going to focus on the MP42 and the Spark-1 during our broadcast. So, let me talk you through the schedule for this broadcast in a little bit more detail. We'll spend the next 5 to 10 minutes introducing our guests and talking about the different satellites that will be flying today. Then, roughly 15 minutes prior to launch, we'll switch over to the SpaceX webcast. Today's launch is a little bit different from other transporter missions because the Falcon 9 is actually going to visit 2 different orbits. The first one, which will be 630 kilometers, is where a few satellites will be deployed right after the second stage finishes its first burn. So we'll stay with the SpaceX webcast for that. The SpaceX will perform an orbit lowering maneuver to get to a roughly 500 kilometer orbit for another satellite deployment sequence. And this orbit change maneuver will take about 55 minutes. So during that time, we'll come back to our studio, we'll talk more with the guests who are going to be joining us remotely, and then we'll switch back to the SpaceX live feed to hopefully see those satellites successfully deployed in that second deployment. So it's time for me to turn to Haraldus, as I said, my technical sidekick for today. Haraldus, first of all, can you tell us, is there anything special about today's launch?
Yeah, Michael, I'm so excited to be here. It feels like it was like 2 weeks since the last time I was here,
yep.
But actually it's like almost 3 months now. And right now there's 3 satellites we launched back in the day. Have already started their payload operations. One more is still in payload commissioning. And today's launch is very special for us for 3 different occasions. So first of all, it is showing the capacity we're building in NanoAvionics, because we had 3 satellites launched 3 months ago. Today we have 3 more, and we have like more than 6 satellites planned for the remaining of the year. So that's quite a growth compared to previous years. Second thing, today we are launching again our biggest satellite so far. So it's a MP42 platform. Yep. So with a January launch, we launched 16-unit RCV satellite. and MP42 is almost 2 times as big as the 60 new satellite form factor, and it is a first ring-deployed microsatellite for NanoAvionics. And I'm so excited that I was working on this project from the very beginning, because it's a stepping stone for NanoAvionics to a bigger industry. And finally, there is one more satellite which is also kind of new to us. So it's an Omnispace Spark-1, which is a 12-unit satellite with first to NanoAvionics double deployable solar panels. And it's a very special mission for me, because it was a first satellite on which I started working on when I joined NanoAvionics almost 3 years ago.
It's fantastic to hear that personal involvement you've had in these projects. It must be a really exciting day for you to see them finally up in orbit and hopefully deployed successfully. And as you mentioned, a really important day for NanoAvionics for a number of reasons. Talk us through in a little bit more detail the 3 different types of satellites that we're going to see deployed today.
Yeah, so let's start from the smallest one. So I cannot disclose a lot of details about the mission, but the first satellite we're launching today is a 6-unit form factor satellite. So as we call it, a shoebox size satellite. It carries on board the Earth observation payload, and even with satellite this small, it has a star tracker, which allows it to do a precise orbit attitude pointing maneuvers and attitude determination, first of all. Then the second satellite on board is, as I mentioned, the Omnispace Spark-1 satellite, which is a first ever to NanoAvionics M12P satellite. It has a double deployable solar panels, which is required because the satellite is meant for IoT mission, and the satellite customer wants to operate satellite with a 100% duty cycle at any point of Earth, while at the same time maintaining the nadir pointing with satellite antennas. So it needed quite a big solar panels, as in the picture here, to generate all the required orbital power. And finally, as I mentioned, MP42 satellite is the first ever NanoAvionics microsatellite. It has multiple customer payloads on board, as well as NanoAvionics' own internal subsystems, such as first ever in-orbit payload controller 2.0.
Brilliant. And we'll hear a little bit more during the coasting phase from some of our guests about some of the payloads that are on board that MP42 as well. Those are the satellites, and thanks for that breakdown. Tell us about the rocket and this SpaceX mission. Can you talk us through the launch and the orbital parameters of this SpaceX mission?
Yeah, so you already gave quite a good description of how the launch will look like. So Falcon 9 will fly to 640 kilometers sun-synchronous orbits in the beginning. It will perform the deployment of a couple of satellites, including Omnispace Spark-1 satellite. It's because it's a multi-stage mission, so it means it deploys first batch of satellites at one orbit and second batch at other orbit. So it was a very good opportunity for us, because we needed a 640 kilometers orbit for Spark-1 satellite. Meanwhile, for Earth observation satellite, the 500 kilometer orbit was better. So once the Falcon 9 performs deployment of the first batch of satellites, it will perform orbit lowering maneuver, which will take around 1 hour, and deploy the next batch of satellites at 500 kilometers orbit, including the satellites built by NanoAvionics, so 6-unit Earth observation satellite and MP42.
Fantastic. So really impressive that we can see those 2 different orbits, and as you said, how they relate directly to the objectives of these missions that are on board. Haroldus, thank you so much for sharing your insights today. Now we are roughly 15 minutes from the liftoff of that Transporter-4 mission on board that Falcon 9 rocket. So it's time for us to say goodbye for a little bit and hand over to the SpaceX webcast to hopefully see a successful liftoff of the Falcon 9 rocket.
Vehicle is supersonic.
Stage separation confirmed. Dragon, separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You're looking at a live view of the Falcon 9 set to lift off at 12:24 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. My name is Yomezo, and I'm joining you from the opposite coast here at SpaceX's headquarters in Hawthorne, California. Today we're launching SpaceX's Transporter-4 mission, our 4th dedicated small-sat rideshare program launch and 12th launch of 2022. On this flight are 40 spacecraft, including CubeSats, Microsats, Picosats, non-deploying hosted payloads, and an orbital transfer vehicle carrying spacecraft to be deployed at a later time. There will be a total of 20 deployments today, which will begin around the T plus 15-minute mark and last for approximately 73 minutes. Due to the lack of ground station coverage at times, we expect only a handful of our deployments will be visible today. However, we do expect to have telemetry and hear audio confirmation over the nets when in range of ground stations. To see a full list of today's deployments, head over to SpaceX.com. And with liftoff in about T-minus 7.5 minutes from now, let's take a moment to learn about the Falcon 9 rocket on your screen. Now, to give you a sense of scale, the rocket supporting today's launch stands about 20 meters taller than the Arc de Triomphe in Paris, France. It's named after the Millennium Falcon in Star Wars and gets the number 9 after the number of Merlin 1D engines at the base of the rocket. Now,
chill has started.
What you can see in that foggy view on your screen are the 4 key parts that make up the rocket. The first is the first and second stage, as well as the inner stage in between, as well as the fairing at the very top of the rocket. Now, the first stage is the bottom 2/3 of the vehicle that you can barely make out there, and that's what we refer to as the booster. Those 9 Merlin engines do the bulk of the work to get Falcon 9 off the ground and up to the thinner parts of the Earth's atmosphere. For today's mission, it will be flying a southern trajectory along Florida's eastern coast, which may make it flight visible from the ground there. At about 2.5 minutes into flight, it will separate and make its way back down to
RP1 load complete.
Back down to Earth. We did just finish stage 1 fuel loading. And again, the first and second stages will separate, with the first stage targeting a landing back on our drone ship. Just read the instructions. Now, for those of you keeping track, today's mission does mark the 7th flight for this particular booster. And on top of the first stage is the black carbon fiber inner stage, which connects the 2 stages and houses the pneumatic pushers that allow the first and second stage to separate during flight. Then on top of the inner stage is the second stage, which will take the 40 spacecraft to their eventual destination in orbit. You may want to watch the velocity gauge that'll show up on the bottom left of your screen to see how fast we're going when stage 1 separates, and then how fast when we shut down stage 2. You'll see that stage 2 actually contributes more velocity than the first stage. Now, right now, the spacecraft are enclosed inside the large nose cone at the top of the rocket. This is called the fairing. The fairing's job is to protect the payload inside until the vehicle is outside the Earth's atmosphere, at which point the fairing halves will separate to expose the satellites to space. Now, today we're flying a new fairing, which you might be able to tell as it's much cleaner
for a strong back retract
than the sooty first stage, which has flown many times before. We are currently just about T-minus 4.5 minutes from liftoff. The vehicle is healthy and we're currently working, no issues. You may have heard that we finished stage 1 and stage 2 RP1 loading, and stage 1 liquid oxygen loading will finish a little over a minute from now at T-minus 3
strong
minutes.
Strong back retract has started.
Heard the call out that the strong back has begun retraction of the transporter erector. You can see those clamp arms below the fairing opening there to allow the transporter erector strong back to pull slightly away from the Falcon 9. Now again, the transporter erector is the structure that provides liquids, gases, electrical connections to the second stage, as well as air conditioning to the payload fairing. You might be able to hear the pops and hissing sounds, and that is from propellant loading, as well as the launch mount and strong back that the propellant is going through. You can see that strong back slowly reclining there from the Falcon 9. As a reminder, you're watching the webcast for Transporter-4, which is our 4th dedicated rideshare mission to date. The payloads continue to look healthy. The Falcon 9 team is tracking no issues on the rocket. We should be finishing stage 1 liquid oxygen.
Stage 1 LOX load complete.
There it is. We just finished stage 1 liquid oxygen loading. And in about a minute here, the stage 2 liquid oxygen should wrap up as well. We do load liquid oxygen in as late as possible so we can keep it as cold as possible so we can load more of it into the booster. You might be able to hear that it is a busy morning here on the factory floor here in Hawthorne, California. We're about 10 seconds from the end of stage 2 liquid oxygen loading.
Stage 2 LOX load complete.
There's the call out for finishing up liquid oxygen loading. Those white clouds that you see coming from the booster are venting from the transporter erector liquid oxygen line. They're on your right. That's totally normal and expected. In about 30 seconds here at T-minus 1 minute.
Gas closeouts have started.
At T-minus 1 minute, Falcon 9 will be in startup. The first and second stages will begin pressurizing for launch, and the internal flight computers will have taken control of the countdown.
Falcon 9 is in startup. Falcon 9, Transporter-4, LD is go for launch.
LD has given that final go for launch. All systems are go. Let's watch Falcon 9 lift off.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mission and liftoff of Transporter-4. Pitching downrange. Stage 1 chamber pressure is nominal.
We're at T plus 40 seconds. Awesome views from Falcon 9 punching through the clouds. Falcon 9 has cleared the tower, and we're currently
Telemetry nominal.
throttling down in preparation for max Q at T plus 1 minute and 12 seconds. This is where the stage will experience the maximum aerodynamic pressure.
Max Q.
There's max Q. Everything is looking good with stage 1 trajectory. Beautiful view of the clouds in the background there. In just about a minute, we will have 3 events coming up in pretty quick succession. There's MECO, which is main engine cutoff, stage separation, which is when the first and second stages separate, and SES1, where that single MVAC engine on the second stage will ignite, carrying...
Start of MVAC engine chill.
You heard the call out for the start of that MVAC engine chill prior, getting ready for that second engine startup. Really cool plumes from Falcon 9. We're under 30 seconds to main engine cutoff.
Main engine cutoff. Stage separation confirmed. MVAC ignition.
There you heard and saw those 3 events happen back-to-back: main engine cutoff, stage separation, and second engine startup 1. You can see those grid fins deploying on the first stage there. In just a few seconds, we should have
fairing separation confirmed.
There's that confirmation of fairing separation. You can see the 2 fairing halves have separated from the vehicle, exposing the 40 spacecraft to the vacuum of space. Now, today's mission marks the first flight for both of those fairing halves, and we will be attempting to recover those from the water once they fall back down to Earth. Now, we're currently in our first of 3 MVAC burns. Now, this first burn should last until about T plus 10 minutes. And the next milestones will be the first stage booster's entry burn. So Falcon 9 executes an entry burn to slow itself down before hitting the denser parts of the Earth's atmosphere. Without this entry burn, relying on just the atmosphere to slow down Falcon 9 would put unnecessary strain on the rocket's structure.
Vehicle is following a nominal trajectory.
The Transporter-4 mission, again, is SpaceX's 4th dedicated small-sat rideshare program mission and the 12th mission of 2022. SpaceX is targeting at least 3 dedicated rideshare flights to sun-synchronous orbit per year, and we also offer opportunities to ride to orbit on our Starlink missions, which launch every couple weeks or so. Small sats can ride to space on SpaceX's Falcon 9, Falcon Heavy, as well as Starship in the not-too-distant future. You can see on those live views from the first stage on your left that Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage, and stage 1 is using these grid fins for steering as it makes its way back down to Earth. Second stage is looking good on the right there in the middle of its first burn, the first of 3 burns. Those white puffs of gas that you may occasionally see from this first stage are from the attitude control system, and those are nitrogen gas. That's nitrogen gas that's coming out and helps with attitude control of the first stage as it makes its way back down to Earth.
Stage 2 FDS is safe.
We're about 3 minutes from the start of our stage 1 entry burn. Again, this is a 3-engine burn, and there are 3 engines in a row on the first stage, which will light up to slow the vehicle down as it enters the upper parts of the Earth's atmosphere.
Vehicle continues to follow a nominal trajectory.
If you are just joining us, we did have a successful liftoff of the Transporter-4 mission, which is SpaceX's 4th dedicated small-sat rideshare mission and 12th mission of 2022. On your screen are live views from the first and second stage, with the first stage making its way back down towards the Atlantic Ocean to land on our drone ship, Just Read the Instructions, and the second stage on your right in the first of 3 planned MVAC burns. We're about 2 minutes from the start of that stage 1 entry burn, which is about a 20-second burn that slows that first stage down as it enters the Earth's atmosphere.
Acquisition signal, Bermuda.
Now for today's mission, the stage 1 landing burn will follow under a minute after the end of our stage 1 entry burn. And that'll land the first stage on our drone ship, Just Read the Instructions. And to put the deceleration of the landing burn into perspective, around 60 minutes or 60 seconds away from landing, the first stage is moving about 2,000 miles per hour. Then in less than a minute, we'll rapidly reduce speed in order to prep for landing, and the first stage slows down to just about 87 miles per hour when the landing legs deploy just prior to landing. The Falcon 9 first stage is equipped with 4 landing legs made out of carbon fiber with aluminum honeycomb, and they're placed symmetrically around the base of the rocket, and they'll deploy just prior to landing. We're under 30 seconds to the start of that stage 1 entry burn. It's a really cool view of the Atlantic Ocean from the first stage on your left.
Stage 1 entry burn startup.
Here's the start of the stage 1 entry burn.
Stage 1 entry burn shut down.
Did have a successful stage 1 entry burn. And as I mentioned earlier, we will be attempting to recover
Stage 1 FTS received.
this booster for the 7th time today on our drone ship, Just Read the Instructions.
Stage 1 transonic.
The first stage has just 1 more burn left.
Terminal guidance.
That's the landing burn. We'll be starting here in just a few seconds. And at the same time, the second engine, the MVAC, will actually shut off at the same time as the start of that landing burn.
Stage 1 landing burn. Seco 1.
There's second engine cutoff 1, and you heard that we did start our stage 1 landing burn. This is about a 20-second burn of the single engine.
Orbit insertion.
As you can see, we did have a successful landing of our first stage, as well as a confirmation of a nominal second stage orbit in the middle there. Now coming up in about 5 minutes, we are expecting the start of the deployment sequence. There will be 20 deployments of 40 spacecraft, which will occur over a 73-minute period of time. Now this includes CubeSats, microsats, picosats, non-deploying hosted payloads, and an orbital transfer vehicle carrying spacecraft to be deployed at a later time. Now, as I mentioned at the start of the webcast, due to the lack of the ground station coverage, at times we expect only a handful of our deployments will be visible today. However, we do expect to have telemetry and hear audio confirmation over the nets when in range of ground stations. Now again, to see the full list of deployments for all 40 satellites on today's mission, head over to SpaceX.com. With that said, the first 3 payload deployments are going to happen during a blackout period where we will lose live camera views and telemetry. There is a possible blackout period when we plan to relight the MVAC engine on the second stage for its second burn at about T plus 28 minutes into flight. Because all critical data is stored and forwarded, we will confirm deployment of the first 3 payloads once we regain ground station coverage in the Maldives around the T plus 57 minute mark. For now, we're going to take a short break during this blackout period, and we'll leave you with the animation of where we are during this time. If we are able to regain coverage for the relight of our second stage engine, we will come back with live views and confirm on screen. But if not, we'll see you back here in about 40 minutes.
And expected loss of signal, keep.
Welcome back to the SpaceX Transporter-4 live stream with NanoAvionics. As a small satellite manufacturer and mission integrator, we have 3 customer satellites flying on board the Transporter-4 mission. We were expecting to see the deployment of the Spark-1 satellite already, and we're not quite sure what's happened with that deployment so far. As soon as we hear details, we will update you on our social media channels, so please do follow those to find out what's happened with the Spark-1. Speaking of social media, after the Q&A and our time speaking with a few of the guests, we're going to have a session answering your questions live, so please do put them into the chat and on our social media channels. But now, as the Falcon 9 enters its coasting phase and we have some time before its lower orbit second deployment, we're going to have a Q&A session with some of the customers and stakeholders involved in the missions on today's satellites. And my first guest is Vytenis, the CEO of NanoAvionics. Vytenis, thank you very much for joining us. And first of all, I have to say congratulations on seeing the successful deployment of Spark-1.
Yeah, so thank you, Mike, for the introduction. It's a great pleasure. You know, it's always a great pleasure to watch and witness successful deployments of the satellites. And of course, you know, all fingers are crossed at the company for the further success of the commissioning of the satellites and, you know, the beginning of their missions.
Fantastic. Yeah, and congratulations to Omnispace and Thales Alenia. We'll be talking to them in just a moment. But before we get into all those nerdy details about the satellites and the technologies on these payloads, Vytenis, could you just talk us through the kind of big picture? What are small satellites? What kind of advantages do they bring in the commercial space market?
Right, so small satellites, in general, it is a pretty new trend.
Mm-hmm.
So when we say small satellites, in most of the cases, we keep in mind satellites of up to 250, 300 kg
mm-hmm.
in their mass. Which means that the small satellite philosophy is to launch a number of those satellites rather than one, but huge and expensive. So small satellites were roughly telling invented to work like in a global scale, covering entire Earth, entire globe, in various geographical locations, in various orbits,
mm-hmm.
in order, you know, to watch the surface of the Earth or you know, provide telecommunication or other tasks real time, literally around the globe.
Fantastic. It's really interesting to see then how that coverage can be important, as you said, the value you can get from many small satellites. But one thing that's interesting about today's launch is the MP42, because this is a little bit of a move away from the smaller satellites like this 6 unit that we have here, towards slightly larger architecture, more payloads, and obviously more resources on board as well. So could you talk us through a little bit the philosophy behind the MP42, what it's for, and also what kind of applications it might be suited for?
Yeah, so when we started the business, everything since the very beginning of the company was driven by the market analysis and trying to understand what do the market needs. It's not like the space is cool, let's build something, you know, let's launch like CubeSats or something because, you know, it's interesting. Of course it's interesting, it's very interesting, and but we were always seeking for economic return. Through those last 2 decades, everything was driven by the launch providers. The launch prices, I mean, to put 1 kilogram into orbit were like crazy expensive.
Mm-hmm.
So like I remember 10 years ago, 15 years ago, the prices were like 8 to 10 times higher than we have right now.
Okay.
So that's why people were thinking to squeeze everything into a small box. I mean, like this, it's a relatively small box. So imagine those boxes 10 or 15 years ago in the mind of the people were even like 6 or 2 times or 3 times smaller than this actually.
Mm-hmm.
But suddenly the paradigm started to shift towards bigger satellites, and I believe it was driven mainly by the dramatically decreasing prices of the launch, which is a good news. I mean, more and more people are starting their businesses based on nano satellite constellations and small satellite constellations. More and more people, getting easier access to orbit. I mean, it's like literally, it's like accessible. Yeah. I mean, you just pay relatively low amount as compared to 10 years ago. I mean, low amount of investments, right? And you can put something into orbit. So those decreased prices of the launches are driving some trends towards heavier satellites, and we discovered let's say first signs of this like 2 maybe 3 years ago. And we started to prepare for today actually, and we started to design what is called today MP42.
Fantastic. So this is 3 years of work and preparation at least to get to this stage today. Right. And talk us through, what are the different applications? What can customers or other stakeholders do on the MP42 that they can't do on a smaller satellite? Right.
So we already have some interesting statistics. We can discuss, we can talk about. But I would say 2 main areas where our customers are working and what we are supporting are related with telecommunication or particularly IoT payloads. The other big part is Earth observation. So I should say that Earth observation, I think, again starts to boom as we were seeing some trends, towards growing applications of Earth observation like maybe 10 years ago. Yeah. So I think now it's coming back pretty strongly. And the remaining part, which is maybe, I don't know, 20% of the payloads we're launching, are related with scientific research, some fundamental research, some technology demonstration, like new equipment, new sensors, new actuators, new computers, new power systems, etc. Scientific and technology demonstrations.
Fantastic. And that might bring us on to another topic to discuss, which is maybe the difference between these dedicated versus rideshare satellites. So just to put that in a bit of context, NanoAvionics offers a really wide range of services in terms of the different stages of development that customers might be at. This is all the way through from sharing a satellite service with multiple clients through to providing end-to-end infrastructure. So maybe you can just explain for our audience what we know what a dedicated mission is. That's where one customer has its own satellite. But what's a rideshare mission? Because the MP42 is a rideshare, and what kind of benefits does it bring, and which organizations might benefit from it most?
Right. So, of course, most of the missions we run are like dedicated missions, as you said, because most of our customers are seeking to, let's say, to do some real and broad-scale business based on nano satellite or small satellite constellations. Yep. But significant part of the launches we perform or we are responsible for are so-called rideshare missions, where we put multiple payloads from multiple customers on board the single satellite. So for example, if you have some certain or very specific or relatively narrow task, like test like new power system, test new onboard computer, test new reaction wheel or other actuator or sensor, rideshare mission is a real cost saver for you, because you do not need to run full mission of the single satellite. You just put your payload there. We are taking care about the data download, about all of the orbital dynamics, mission control things and everything. So you just don't do a lot of complicated tasks. You just test your thing, you get the data, and that's it. The mission is done. So this is the essence of the rideshare missions.
Brilliant, and a really clear use case how you can test out those different payloads, those different technologies. Speaking of payloads then, does NanoAvionics ever have its own payloads on these rideshare missions?
Yes, actually we do have those payloads quite often because, you know, technology is like living organism. I mean, it's never perfect. But even though it is never perfect, it gets old very fast.
Right.
So you always have, you know, to develop something, software, hardware. People around the globe are inventing new sensors. So, you know, you see how to improve things. So quite often we put something new on various missions. Of course, we make a calculation not to increase the risks of the mission. So most probably it will be like, you know, like secondary instrument, which is not like, you know, which is isolated, and if it fails or if it doesn't work in space environment, it do not damage the entire mission.
Yeah.
So yes, we do this, and this is, you know, this is a part of the technology development, of the constant technology development. And of course, MP42 is not unique from this perspective. It also contains some new technology. We have their payload to test under the GIOT program, which is a European Commission funded program where KSAT and Space are the partners of the program, and we are developing inter-satellite link through the GEO satellite. So this is very important, you know, this is a very important milestone for that particular program and for NanoAvionics in general. Yeah. And there is one secret payload. I cannot reveal any details about that at the moment, so please follow, and you will be, you know, you will get some surprises.
Brilliant.
in the near future.
Great reason to keep following us on social media to see what that secret payload is. Brilliant, Vytenis. Let's finish up with just, you know, a couple of personal reflections. So you've been at launch days before. What's the experience like? Talk us through some of the launches you've been at. What does it feel to actually be there, to see the satellites that you've worked on, you know, go up into space?
It's a wonderful experience. It's a really wonderful experience, and I recommend to any person, even though the person is not working in this area, to watch it, you know, once, maybe twice in a lifetime, because it is a really different thing from what you see in the screen. My first launch I've been attending and watching was Lithuania Sat-1 launch back in 2014. Okay. Performed by Orbital Sciences in Wallops Island. I mean, it's like south of Washington DC. So yeah, it's really spectacular experience. I mean, that noise which is coming from the launch vehicle, I mean, you can feel it in your chest. I mean, all of that, you know, all of that power, and the plume is so bright. So it's really, you cannot forget it. So after that, yes, I've been watching a few more launches, and it's like, you know, it's a very short thing. It happens like in, I don't know, 30-40 seconds, and it's gone. But the experience you have, I mean, yes, you can never forget.
Fantastic. And great to have seen a successful launch, a successful first deployment of Spark-1, and fingers crossed for the deployment of the other satellites. Vytenis, thank you so much for taking the time to talk to us and give us that big picture on the industry and tell us a little bit more about ride shares. Now we're going to dig deeper into some of the technologies on board the other payloads that we have on the MP42, and also but first of all, we'll talk to the teams from Omnispace and Thales Alenia. John, Julie and Benoit, thank you very much for joining us. Unfortunately, we don't have confirmed status yet on the deployment of the Spark-1 satellites. nevertheless, it'd be great to get some of your insights on what you have planned for Spark-1 and also the soon to be launched Spark-2 satellites.
So we have another satellite which will launch soon called Spark-2, and we'll be sharing more news on that shortly. The Omnispace Spark program will serve to advance the development and implementation of our global 5G NTN network. And once completed, our new generation of LEO satellites in our NGSO constellation will operate in Omnispace's global 2 gigahertz S-band frequencies. And this Omnispace Spark program will support the mobile industry's 3GPP standards operating in band M256, making connectivity possible for direct-to-devices from space to any compatible device.
Brilliant, John. Thank you for painting that picture of what Spark-1 means and the start of this incredible journey and process that you guys are going to be on developing your constellation further. I'd like to turn now to the team from Thales Alenia. You guys are used to working on obviously huge space projects. You've been working for 4 decades on the largest space projects. But in this case, with the Spark program, we're talking about small satellites. So presumably, even though the satellites are small, the technical challenges were not necessarily small. Can you talk us through some of those puzzles?
So yes, you're right. Thales Alenia Space is a major actor in space domain, delivering solutions for navigation, telecommunication, Earth observation, space exploration, and science. So around Earth, at every altitude, you can find satellites that has been made by Thales Alenia Space. Our motto here is Space for Life. So we believe in space to build a better and sustainable life on Earth. To accomplish that motto and that mission that we got, we build different sizes of satellites at different altitudes. So the biggest one that we made is about 6 tons and 8 meters long. And now we get the smallest one, as you can see behind me. That's the smallest one, is 15 kilos and is 1 meter long. So we are very excited about that program and about the launch today. And for the technical challenges, I will let Benoit develop.
About the technical challenges, I can say that the main technical challenges were to develop a full software-defined radio mission instrument to allow the evolution of the signal management versus the customer needs, and to make it compatible to the platform provided by you guys, NanoAvionics, in terms of interfaces like power and data links in a short period of time. In addition of those technical challenges, we had also schedule challenges. We need to develop and build both satellites, 2 satellites, sorry, in less than 2 years with the COVID pandemic. So it was very difficult at the beginning of the project to travel, to go to Lithuania, to your premises, to work with you guys. But as soon as the borders were open, it will be easier to work together and to travel to Lithuania to make some tests and so on with you in your premises.
Fantastic. And tell us a bit more about the engineering puzzles that you had to solve for these complicated communications missions to work. How did you collaborate with different partners such as NanoAvionics to solve some of these puzzles quickly?
Yeah, so our strategy was to be agile since the beginning, and for each development steps. We adapt our standard processes and to fit this new space world. And for example, we reduce the papers. Okay, we produce less documents. We go to the essential. So to solve the puzzles, as you said, we worked in integrated team in our main partners. So Thales Alenia Space developed the applicative software for the mission. We had NanoAvionics that developed the platform, Searlinks that developed the instrument, the mission instrument, and Anyways was responsible for the S-band mission patch antennas. We created a very strong and trust relationship with our customer and our partners. Okay, so with Omnispace, we were transparent in our communication, so we could exchange very easily, quickly, and react and make the trade-offs. And we answer the needs. We fulfill their needs. And we learn how to work with our new partners like NanoAvionics. That was the first collaboration that we had together. And also Anyways, that was the first time also that we worked with them.
Yes, it's true. We work end-to-end with each subcontractor of this program, and especially with NanoAvionics. We try to define a close relationship with each subcontractor of this program. For example, about the integration activity, Thales Alenia Space team went to NanoAvionics premises to realize directly the integration of the instrument inside the satellite and perform in an integrated team with NanoAvionics team functional test, software test, and electrical test.
Fantastic. Thank you so much for going into some of the detail about those technical challenges. So, John, let's bring you back in because you mentioned earlier the Spark-2 satellite production, which is going to be part of your growing constellation. And obviously, this launch is just the beginning of a much wider rollout for you. Talk us through the big picture of 5G, satellite 5G, and IoT communications, and why they're so important to develop. And what could some of the advantages of bringing these cell towers to space be?
Yes, exactly. So 5G from space is going to be very important in the future. And Omnispace is reinventing mobile communications by building a global 5G end-to-end hybrid network that's going to benefit users that require true mobility everywhere. And so the advantage of delivering mobile connectivity direct to devices from space is it's going to allow seamless connectivity across satellite and mobile networks, which will empower mobile network operators and value-added resellers, which will fuel innovation, power industries, connect billions of users, and provide security and network interoperability all over the world. So Omnispace's global 5G capability from a single network will transform industries, serve as a communication infrastructure to support the economies of the future, including true global connectivity, connected car, autonomous vehicle, global supply chains, and global enterprises in general.
Wow, that's a really huge range of impacts that you're going to have with this program, this constellation, and fantastic that the first step in that huge project is underway. One of the interesting features that I'd like to touch on briefly is we mentioned that on this transporter mission there were actually two different orbits that the satellites are being deployed on. So why was that orbit chosen for Spark-1, and what are some of the benefits for 5G operators of that particular orbit?
Yes, so the 5G orbit that we selected, 630 kilometers, provides you with some advantages from a coverage perspective and also from a link budget perspective. Closer is better. So the 630 kilometer orbit allows us to make the link to user devices, mobile devices on the ground. And so we've done a lot of analysis to understand what the issues are associated with deploying a 5G network, and Omnispace has determined that 630 kilometers is our optimal configuration for the Spark-1 program and also our future NGSO constellation.
Perfect, and great that the Transporter-4 mission could get you so close to that final orbit from that first deployment. So thank you very much, John, Julie, and Benoit from Omnispace and Thales Alenia for joining us here today.
Yes, and thank you from Omnispace as well.
Great. So we'll look forward to seeing the rollout of Spark-2, and we'll watch that space. Now it's time to turn our attention to the second satellite that's being launched today after the Falcon 9 has been through its coasting phase, which is the MP42 rideshare mission. As you know, it hasn't deployed yet. Hopefully in roughly 30 minutes, we'll see a successful deployment of the MP42. But in the meantime, let's talk to Omar Casey. Omar Casey is the CEO of OQ Technologies, and they have one of their 5G cell tower in space on board the MP42 today. This is part of OQ Technologies' growing 5G, IoT and machine-to-machine communication constellation. So Omar, it's great to have you with us. Many thanks for joining us.
Hi, thank you very much, Michael. It's a pleasure to meet you. I'm very happy to be here again.
Great. Let's kick off by mentioning that the MP42 is not your first mission with NanoAvionics. Actually, in 2021, you launched the Tiger II nanosatellite, which has been performing operations for some time now. So it would be great if we could get a quick overview of what technologies and services you're developing at OQ Technologies and how Tiger II has been performing and supporting that.
So OQ Technology is the world's first company and only company providing 5G Internet of Things and machine communication by deploying a low Earth orbit nanosatellite network. And the idea here is really we want to extend the coverage of cellular communication everywhere in the world so that users could roam freely between terrestrial mobile networks and our satellite network. Back in 2019, we tested for the first time in the world narrowband IoT technology with a low Earth orbit satellite. That was our Tiger I mission. And as you mentioned, last year we launched our first commercial mission, the Tiger II, together with NanoAvionics and spaceflight on a Falcon 9 rocket. And this has been performing very well. In fact, we from day one when we switched on the satellite, we had signal acquisition. The payload was performing very well, both in uplink and downlink. And we were able to do a lot of service pilot tests with our customers. Some of these very large companies, some are Fortune 10 companies, and they were impressed with the performance of the service. So we were actually deploying our user terminals that allow the users to collect data from sensors and send the data to the Tiger II, and then it goes to the cloud where they could access their data. And it was impressive. We even had indoor coverage. Even when you cover the terminal with the sand or put it inside a car and drive around, we were still able to detect the signal and relay the data. So this is very revolutionary for us. And we're still actually continuing our pilot program. So anyone who would like to sign up for our demo kits, they can contact us and we'll provide them that to do testing of the service with our Tiger II satellite.
Brilliant. Really impressive progress and great to see how successful that is in terms of what you can provide to those huge clients that you're mentioning. Let's talk about the future. So on board today, the MP42, you have your new payload, and when we hopefully see that deploy in a few minutes' time, that will mean another operational payload in orbit. Talk us through what your plans and vision are for the future and how the MP42 payload can contribute to that.
So the MP42 will host our third mission, which is the Tiger III, and it's actually the same payload as Tiger II, but the difference this time we're hosted on a bigger platform, so a microsatellite. And this is very interesting for us because we are trying to look into the possibilities of using more power of the satellite platform to deliver service, higher capacity, see how that will be in future. For example, if we want to add more beams or more narrowband IoT carriers to address larger number of users and higher capacity, we're going to be using microsatellites. So it's a very unique experience for us. We're going to learn a lot from it. But at the same time, we're adding this to our constellation. So the Tiger III will join its Tiger II companion. And that allows us to offer more passes per day for the users. So today, if they have 2 passes per day in one area, they're going to have 4 passes. And we can do more applications with that, for example, smart metering or uploading larger amounts of files, also testing firmware updates and on the downlink. So that's the benefit of using the MP42 Tiger III mission together with our Tiger II.
Fantastic. To finish up then, a bit of a broader question, because a lot of your technologies are aimed at democratizing access to 5G, democratizing the use of satellite communications through, for example, cheaper and more affordable components. Could you talk us through then, you know, satellite communications have typically been seen as rather expensive compared to ground networks, and that's maybe one of the reasons they've been synonymous more with remote communications. where higher costs could be justified. Do you think this still holds true for 5G IoT, or might we be seeing, as we see a reduction in the service costs, wider adoption around the world of this technology?
Indeed, 5G will actually revolutionize the satellite telecommunication world because it's bringing a massive scale. Because of the scalability, the technology is scalable, is made for millions of users. You have already an existing ecosystem with multiple chip vendors, multiple operators, multiple device manufacturers, and that actually will reduce the cost dramatically, both for the hardware and also for the service. And it will be different from what has been offered before in the satellite telecommunication world. From day one, we looked at 5G technology as the key for the future for machine communication and IoT. As you know, there are a lot of proprietary technologies out there like Sigfox, LoRa, and all. We see them disappear slowly, while the global standard of cellular is what is staying and what will continue for the future. And that's why we decided to use that and bring it to the satellite world. To give you an example, what we are working towards in the future also is to provide the world's first hybrid terrestrial satellite narrowband IoT and LTE-M chip, which can allow a lot of users. We are collaborating with a US company, Aleph Semiconductors, in order to deploy our IP on that chip, which is already existing for narrowband IoT applications. And that will open the door for a very massive amount of users who can take benefit of this new technology for a very low cost chip that costs the same as a cellular chip, but can do at the same time both terrestrial and satellite communication. Also, we're working on very advanced payloads for future to host more advanced 5G IoT stack for the base station on the future upcoming satellites.
Fantastic. Omar, huge potential with what you're developing, and brilliant to see that big picture to finish off our conversation here. Thank you so much for joining us and sharing your insights. And do stay with us so we can get your reaction when we see, hopefully, a successful deployment of the MP42 satellite.
Thank you very much, Michael.
As we mentioned, the MP42 is a rideshare mission, and alongside OQ Technologies, we're going to talk now with another customer who has a payload upon that mission, which is Veoware Space. Veoware Space specialize in R&D and manufacturing of attitude determination and control solutions for spacecraft. These include high performance, low power consumption reaction wheels and control moment gyroscopes for small satellites. And I'm delighted to say we're now joined by Julien Tallineau. Julien is the CEO of Veoware. Julien, thank you very much for joining us here today.
Hello, Michael. I'm Julien Tallineau, indeed the CEO and co-founder of the company Veoware Space, and I'm extremely happy to be here today with you.
Fantastic. Well, so clearly there's a strong trend of hardware and products that support satellite operations in space, and your payload on board the MP42 is addressing an important issue for many small satellites. Could you explain the problem that Veoware is solving and how your payload on board the MP42 contributes to that solution?
Basically, the problem is very simple. Every single satellite these days needs to control or maintain the orientation in space. This is referred as attitude control. And this is very important for satellites to control their attitude to successfully perform their mission. Let's take telecommunication satellites, basically. They're required to point towards the right antennas on the ground or to connect the different users for telephony or television or simply the internet. Also, you have Earth observation satellites, which are required on a daily basis to collect imagery of the planet over cities, over coastlines, over agricultural fields to understand how the yield is coming, or even sometimes for defense purposes to ensure the citizens' security. On the other hand, you have also science satellites that are required to point very accurately to the stars or to different galaxies to understand the universe. And all of that is only enabled by attitude control systems such as the reaction wheels installed in MP42. And today, Veoware is extremely proud to put the next generation reaction wheels on the market thanks to NanoAvionics, and that actor is now coming to space basically with MP42.
Thank you very much, Julien. A really important solution to clearly an important problem as well. could you give us a bit more technical details on the reaction wheel that's flying on the MP42? And tell us a bit more about how your reaction wheels and control moment gyroscopes stand out in the market.
So the reaction wheel basically is serving satellites from 35 kilogram to 100 kilogram. And it meets 5 of the key performance metrics that customers look at when they select reaction wheels. The first one is compactness. Our reaction wheels is extremely low volume and can fit anywhere into your satellites. Second, the power consumption. With only 3 watts power consumption, the reaction wheel is really not hungry, and it will be very pleased to use the resource of your satellites while offering the best for its kind torque performance. Fourth, the cost. Veoware took great care of making sure that this package of volume, power and torque comes at very competitive price for small satellite customers. And last but not least, the lead time. We believe at Veoware that small satellites and mostly their constellations require very short lead time, basically less than 6 months, with our target now less than 3 months when our production line will be in place by the end of 2023. This is about our reaction wheel. Now let's look at the control moment gyroscope, which is another kind of actuator. This actuator is made for satellites from 50 kilogram up to 300 kilogram. It's a much more scalable actuator compared to reaction wheels. It's also way more capable than a reaction wheels for multiple aspects. The first aspect is that a control moment gyroscope is made for agility. It offers satellites to rotate 10 times faster than a reaction wheel. And this is extremely important for satellites, specifically in Earth observation, that needs to collect more pictures and eventually generate more revenue selling those pictures. And this is only enabled with the first of its kind small control moment gyroscope that comes at the price that small satellite customers are prepared to pay. All these 2 technologies now are coming to market. The first one being the reaction wheel installed on MP42 satellites with NanoAvionics. This one will be available for sales basically by the end of this year, and we very much look forward to having all the feedback from customers and also from NanoAvionics, which we're extremely happy and proud to work with today.
Many thanks, Julian, for answering our questions in so much detail, and do please stay with us so we can get your reaction when we see the successful deployment, hopefully, of the MP42. Since Julian was our final guest on this Q&A, now it's time to switch to some live Q&A. On our live stream, there's the option to ask some questions to 2 of our experts who are in the other studio, Gilvinus and Arnoldus. So we're going to switch over to them now, and they'll be answering live your questions about this launch and the satellites on board.
Hello everyone. So unfortunately today Arnold and Gilvinus are not able to participate in a Q&A session. Therefore will me, Julius, BD manager, and
Ernestus, CTO of Non-Avionics.
Yeah, we're taking over to answer some of your questions. Of course, congratulations to all our team with a successful launch and deployment of the first satellite. After the Q&A session, we will continue the live stream and deployment of the next 2 satellites. And in the meantime, we'll cover some of the questions. So maybe we can start with a brief introduction. I know we have a question about how Non-Avionics started and how old is the company. So actually the company was founded back in 2014 and by original company founder Vytenis. So the company started by producing and designing components for small sats. So it's actually, I think the first component was the OBC for the CubeSat. So that was, I would say, a tough start, but good start for the company. The another question we have actually about one of our components is about the reaction wheels. Would you like to answer that?
Yes, so yeah, the question is how does reaction wheels work? So it's actually a very good question because reaction wheels are like one of the most important subsystems for attitude control. So simply speaking, in simple terms, it means that you can point the satellite to specific targets on Earth, or points, for example, solar panels to the sun. So the idea is that it has a motor and rotating mass inside, and by rotating that mass, you can counter-rotate the satellite to the opposite direction. So by controlling those reaction wheels, you can control the attitude of the satellite in the orbit. Of course, reaction wheels is just one of the subsystems in the satellite. The attitude control and determination subsystem itself, it has many sensors and many actuators. For example, it also has magnetorquers to the satellite reaction wheels. It has sun sensors, it has magnetometers to understand where the satellite is pointing at the specific moment, and so it could take actions over controlling reaction wheels to point the satellite to a specific direction. So it's actually complex system, and reaction wheels are just one of the attitude control determination parts.
Yes, so we actually have another question about what other most important subsystems are on the satellite, and maybe you can tell us more about that as well.
Yeah, actually, we could speak about this question probably for an hour, and but really briefly telling there are like few main subsystems. So first of all, maybe we can start with the solar panels, which gathers energy from the sun, power ups the whole satellite. So solar panels are connected to another subsystem. It's called electrical power supply. So it is responsible for taking the power from solar panels and charging the batteries. So the satellite also could operate in eclipse when there is no sun. Yeah, and of course the EPS is also responsible for powering up all of other subsystems. So, and we have many of those. For example, onboard computer, as Julius mentioned, was one of the first subsystems in NanoAvionics. It is responsible in our case for also attitude control determination, what I told you before. Also, it gathers all the telemetries from sensors, controls all the operations of the satellite. Also, we have a payload controller, which is responsible for mainly running tasks for the mission itself. For example, it can run scripts, operate the payload, gather the payload data, store it in its storage memories, then later on it connects also with the communication subsystems, and communication subsystems don't lose the data. So yeah, communication subsystems are other important part, because it's really just the only way to contact the satellite. So typically we have low data rate UHF radio. It's more for commissioning and for redundancy. Then we have S-band and X-band radios for high data rate transmissions. So those are responsible for typically downlinking payload data, which most of the times can be tens, even hundreds of gigabytes of data.
Yeah, so simply saying there's not important systems on the satellites. So to have a successful mission, we design the satellites to have the systems for the successful mission to achieve its actual purpose.
Yeah, and we can configure the satellite according to the customer requirements each time. So it means that sometimes one of those subsystems can take more of satellite volume, sometimes less. So this is really job for our systems engineering to do, and to configure the satellite according to the customer requirements.
Yeah, and actually that leads us to another question. If we have any Earth observation missions, and we actually have launched with today's satellites, so we have 3 Earth observation missions in orbit. So we have gathered quite a bit of experience already. So of course we can mention that the NanoAvionics CubeSat 1U had also Earth observation payload, a camera.
Right.
Of course, it was a very low resolution camera, and we wouldn't call it a real Earth observation mission, but still, it's a similar type, I would say. These satellites that we're launching, let's say today, these are much more complex. They have quite a high-end solutions inside, and the cameras are very high resolution. We are actually able to achieve quite a significant pictures, I would say, with them. Okay, so another question. Do you want to take this one? No?
No. It would be, which one you're talking about?
Okay, so let's take this one. Do you know what kind of satellite do you need for your mission? What should you consider? Okay, so basically, I think as far as I understand, how should you know what kind of satellite you should have?
Yeah, so already mentioned a bit of that. So really, it's our typically how it goes. We get requirements from the customer. So most of the cases, customer already comes with this idea for the mission. In most of the cases, with really exact and concrete requirements. Then it goes. Those requirements goes to systems engineering department, where they design the satellite, design size, as I mentioned, the main subsystems. For example, for one of the satellites, it could be that the payload requires a lot of in-orbit average in-orbit power. So then it means that more solar panels would have to be placed inside the satellite. Maybe for other missions, it requires more, data throughput for payload data, but not so much maybe of the power. So then we configure the satellite with the X-band radio. Sometimes it can be that pointing is required, really accurate pointing of the satellite, the attitude, change of attitude, as I mentioned before. So then maybe we have to add star trackers, which really are accurate for acquiring attitude of the satellite. So it's really a system engineering job to configure that satellite, and then we propose propose for the customer the mission idea, how big will be the satellite, what subsystems will be included.
Yeah, and we actually, from the high-level approach, we can, we have a couple different approaches. So either the customer can come up with the requirements for the platform with their own payload. If the customer has its payload, they know what they want to achieve with the satellite, with the mission. So they come to us with their requirements, and we configure the satellite to achieve that. And of course, there's another approach where the customer comes with a type of data they need and ask us to configure and find the payloads and provide the full solution, turnkey solution, to achieve the mission, to get the data they need.
Right.
Okay, let's move on. Okay, so I can take this one. How many people work at NanoAvionics? Actually now we are over 130 people in the NanoAvionics group.
Yeah.
And where there's actually another question following is where are you guys based? So we are now in Vilnius. Actually, our main headquarters currently are in Vilnius. We have a small engineering office in Kaunas in Lithuania as well, and we have a quite significant, I would say, our branch in UK, and of course in US. We are growing quite quickly. We have projects in US and UK, and of course the major manufacturing procedures are done in Lithuania and Vilnius. The next question is actually about the number of satellites launched. So, do you remember?
Already probably lost the number after probably 10th of the satellite. No, we have like 15?
Yeah, actually with these today launched, it will be 17 in total. It's not the missions that we did. it's actually our own let's say missions for the clients, or rideshare missions?
Full launch satellites.
Yeah,
it's from scratch, from designing from the beginning till.
In total, we have touched more than 100 missions overall, so quite a significant achievement, I would say. Yeah, and I can see that we have a couple of questions in regards with you know, if anyone would want to join our team. So maybe, you know, using this opportunity, and sure, I think that we can twist it a bit around. Maybe you can tell a bit more what people now we are looking for. I mean, what are the key challenges for the engineering and
yeah. So actually, yes, as Julius mentioned, we already have like 130 people working on avionics, but we're looking for, I don't know, probably at this moment we're looking for 20 or so. We have like 20 open positions. You can find all of those in our website. We really, I mean, probably we're looking for every engineer in each field, I would say, starting from software engineering, electronics engineering, systems engineering, mechanical. So yeah.
Also BD as well, yeah, administration. I mean, we need people almost in every area.
Yeah. So the main, probably the most important factor is if the person is really motivated to work here, and what kind of background does he have. So we're really looking for clever people, for really motivated people, and if you have a aerospace experience, it's perfect then.
Yeah, I would say the experience is the key. We have a strong team. We are all passionate about what we do. I mean, I think it would be hard to find a company in the space industry, you know, that don't like things that they do or develop. So it's very similar with us. Okay, so let's move on to the other questions. And yeah, actually that's a question about the MP42. So it's saying that you mentioned that this will be your first satellite deployed from the ring. How did you deploy the satellites previously? Maybe you can tell more people to how it's done with the smaller satellites.
Yeah, it's actually really a really important topic, I would say, because yeah, we're launching the first ring deployed satellite, and this is really like thinking out of the box. Previously, all the satellites were made on so-called CubeSat standard. So they were, first of all, they were deployed from the specific dispensers, and they had some specific envelope that they had to be fit in. So it means that if you, for example, would like to have really big deployable solar panels, or maybe some kind of dish, for example, antennas, helix antennas, deployable ones, which is difficult to fit into the standard satellite, then this is the solution. I mean, it really opens, first of all, from mechanical perspective, the variety of payloads that could be put into the satellite, and most of the cases, from some point, it can be even easier to design this kind of satellite, because yeah, the bigger satellite previously we had was 16U, and it was really, I mean, completely filled with all the subsystems, all the electronics and payloads. So it was really hard to design, really to fit every part inside. With the ring deployed satellite, you have easier mechanical integration, I would say. Of course, it adds new challenges, new design of the frame would have to be made, but in some cases it is really answer for some of the missions. So MP42 is a rideshare. In this case, we're launching a rideshare mission, so it has few different payloads that it was mentioned previously, and yeah, because of its size, it was really easy to integrate all of those inside.
Okay, so I think that I can take this one. Linus asks, why do you make small satellites when you can make big ones? So actually, there's quite a few points on that. I mean, it's it's more cost efficient. I would say, of course, it depends on the mission. Not every mission can be done with a small satellite, but if you have some scientific mission, small mission and small payload, it's of course more efficient to have a smaller payload, a smaller satellite, because it's a lot cheaper to launch and actually operate a small satellite. So it's kind of also the lead times. I mean, the difference between the lead times for the big satellites and the small ones is significantly lower lead times for the small satellites, at least for quite simple configurations.
Yeah.
Yeah, and all the things. I mean, let's take for example, like laptops. They're getting also smaller, compact, thinner.
Yeah, the mobile phone. I mean, you have like a personal computer inside your pocket. So
exactly. So that's the thing. So the technology gets more compact, and we can fit more into smaller space, and also the more smaller CubeSats. Yeah, we have a question from Julie, and it's, what do you do if a satellite is low on battery and turns off? I think that's a question for you.
Yeah, so first of all, it's really a system engineering job to size the solar panels inside on the satellite, that it would not go into this mode. But actually, EPS is responsible for. I mean, it has different configurations. So typically, you can have fully on satellite configurations where all the subsystems are on and they're working in their designed configuration. Then, if satellite goes for some kind of the reason low in power, it can switch off some of the subsystems and still operate. So typically, you have different modes in the EPS. We configure that before the launch. Our systems engineers are responsible of doing that, of rethinking all the possible modes. So this is just in general. I mean, it's not just what will happen if the power generation would be lower. I mean, there are like many different modes which our engineers have to rethink and have fallback solutions inside the satellite. So it would be like really, I would say, foolproof. So it could fly by its own, by even not having any communication with the ground station for some time.
Yep.
So it could recover from some maybe effects where maybe some subsystems stops working, for example. So we have really robust system in the EPS level, where it checks all the subsystem telemetries, I would say, in simple terms, and
a health check.
Health check, right? And depending on that, it decides what to do next.
Yeah. So we have actually a couple of minutes left until we get back to the live stream of the deployment of the last satellite. So what happened during this period? It's actually the rocket has descended to 500 kilometers and will be deploying the remaining satellites in this orbit. So we wish you all a good live stream, and we also hold our thumbs that everything will go well. Of course it will.
Yeah, it's SpaceX.
So then it's our operations team job to catch the satellites and start the LEO phase, and afterwards the nominal operations.
Right.
Thank you everyone for joining us.
Thank you.
And have a nice evening.
Welcome back to the webcast for Transporter-4, SpaceX's fourth dedicated small-sat rideshare program mission. We had a successful liftoff at 12:24 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. As I mentioned, this is our fourth dedicated rideshare mission. Our goal with these rideshare flights is to provide small satellite operators with the competitive pricing, increased flight opportunities, and flexibility. These dedicated rideshare flights to sun-synchronous orbit will occur around 3 times a year, providing regular access to orbit. Additionally, we also offer opportunities for a ride to orbit on our Starlink missions, which launch every couple weeks or so. So we have 40 spacecraft on board today's mission, spanning across 20 deployments. That includes CubeSats, microsats, picosats, non-deploying hosted payloads, and an orbital transfer vehicle carrying spacecraft to be deployed at a later time. So far, we've had 3 confirmed separation events and are currently waiting to hear the call-outs for another 9, which occurred during a blackout period with no access to ground station coverage. Now again, to see a full list of all deployments, head over to SpaceX.com. Now let's listen in to hear the confirmation of those 9 deployments here shortly. Now we should get that confirmation.
9 payload separations confirmed.
There, we just got that confirmation of
Acquisition signals forward.
of 9 confirmed payload separations and a brief glimpse from that Falcon second stage. That confirms the second set of deployments. So far, we've had 12 out of 20 successful deployments. And in just under a minute, we are about to start our last batch of 8 deployments. So over the next few minutes or so, we are expecting to hear the call-outs for the remaining 8 deployments. It's also worth mentioning that because many of the spacecraft are being deployed in groups, we may not be able to confirm every deployment in real time, but you should hear most of the deployments called out by the operators on console. But for any we don't hear...
25 separation confirmed.
There's that first one. But if there's any you don't hear in real time, we'll try to provide updates by the close of the webcast. Let's listen in.
You said 26, separation confirmed. Hawk 4C, separation confirmed. Hawk 4B, separation confirmed. Hawk 4A, separation confirmed. Acquisition of the signal, Thule. MP42, separation confirmed. Link, separation confirmed. SCV-005, Almighty Alexius, separation confirmed.
Hello, welcome back to our live broadcast, and fantastic news. We've seen that successful deployment of the MP42 satellite, which means that all of the missions we had on board today, the Transporter-4 mission, have successfully deployed. Congratulations to everyone here and to all of the teams. Harold, you must be feeling great, having personally been involved in some of these missions. Congratulations to you, and could you help us out, talk us through the next steps for these satellites now they've just deployed?
Yeah, so with SpaceX job done and Exelon job done, our operators team job just begins. So today is the upcoming most thrilling hours. So after a few hours, satellites will start transmitting the beacons, and we will basically trying to catch them in space. So it's the most thrilling moment for our operators team, because sometimes you don't know exactly correct position of a satellite in space, and it might take a couple of ground station passes to obtain a stable contact with these satellites. And this moment, when we finally get a stable contact, is just as exciting for us as to see the satellites being deployed from launch vehicle. So basically, after the first contact, the satellites goes into LEOP mode, and then our operator team performs various health checks and tests of all the satellite subsystems. before proceeding to payload commissioning, where we check the payload's telemetry, send them to customer. We get a confirmation that the payload operates nominally, and after that we step into nominal operations mode when the payloads start to perform their intended mission.
Fantastic. Thanks for that breakdown. And once again, congratulations. As you said, a really exciting moment for you and for everyone on the team here. And we'll keep our fingers crossed for those first beacon signals. Let's turn now to Omar. Omar, we've seen the successful deployment of the MP42 satellite mission. How are you feeling? What's your reaction to seeing that?
Well, I'm feeling very happy. I mean, I'm so happy that Tiger 3 is joining Tiger 2. Now the real work starts. We have a lot to do, but these are the critical moments where you hold your breath, you know, until successful deployment. But you know, we're confident, and as we see, it's successful, and I'm so happy about that. Thanks to all the teams involved in making this mission a big success.
Fantastic. Thanks for your feedback and your experience and sharing all of your points of view today, and congratulations to you and to the OQ team. Let's turn to Veoware and hear from them as to how they're feeling having seen the successful deployment of that satellite as well.
Michael, we're thrilled about the news. We've watched the launch together with our team today, and since the creation of the company back in 2016, this is the biggest event for us, our first product finally into space. But the work is not stopping here. Our test campaign will start in a couple of weeks, where together with the operational team at NanoAvionics, we'll be doing the performance testing, the electrical testing, and further testing on the entire product for the couple of next months following. And this is where the product now comes to market for other customers to use, followed later this year by the control moment gyroscope. So at the moment, we're extremely happy. We're going to celebrate over the weekend, and we're going to keep working on both the collaboration with NanoAvionics and future product, because this is only the beginning. Thank you very much, Michael.
Fantastic. Well, congratulations to the whole Veoware team, and once more, well done, and a huge thanks to Omar for joining us, to Harold for joining me here, and for all of your technical support in explaining this broadcast, and to everyone who's been involved in these successful launches. Do stay tuned to our social media channels, where you can track the progress of the Spark-1 and MP42 satellite missions, and you'll also stay informed on upcoming launches that we have. As Harold said, there are 6 more satellites scheduled to be launched this year, so do keep a close eye on those and make sure you tune in to our next launches. But for now, that's us for this live broadcast. Thank you for joining us, and see you next time.